Did I say that?
I don't know.
I don't think I said that, did
I
I?
think you said it was optional, at least in the web work it said.
The web work is definitely optional. Why don't you just get it done, and that would be a good start. And maybe it'll be extra credit.
Yeah.
Would it help to get it done if it was extra credit?
We'll probably still do it.
Yeah, why not, right?
Yeah.
Gives a shit. Yeah, sure, it's extra credit. So the final is just going to be on counting. So all that entails, like basic counting, multiplication rule, division rule, all that stuff, combinations and permutations, and then basics of graph theory, which pretty much was the last lecture. Yeah, this pen is supposed to be new. Came out of a box. Disappointing box. And then today, just one weighted graph algorithm. So Dijkstra's, boy, these are just the worst pens. Dijkstra's algorithm. And that's like a Swedish name probably or something. I always have trouble saying it. It's like, yeah, I'm not gonna try. Dijkstra's. I like had it down, now it's like totally gone. So this stuff is all for just basic unweighted graphs. There's no numbers assigned to the edges. What we've got today is weighted graphs. So, Tracy, you with us? Mm-hmm. All right, cool. Thank you. Thanks. So a weighted graph is like a network, but there's costs associated with traveling each of the edges. So let's get one up here. Let's get like a nice basic one. Ah, shit, I'll just make one up. We will just make one up and start there. So let's get this one nicely connected. So I've got 4 or 5 different nodes. And the cost of traveling from one node to the other varies. Let's do 3 for that, 2 here, 4 and 1. And one of the great problems in graph theory is the shortest path problem. And this is basically every time you pull up Google Maps or Apple Maps and you say, find me the best route from here to there, it is a shortest path problem. And the thing that's being optimized there is the time. So these aren't distance per se, but actual time of travel. The algorithm we're going to talk about today, Dijkstra's algorithm, I think that word goes better when I don't worry about saying it, it just rolls out then. This is the one that's actually used in Google Maps. So it's a really cool algorithm to use. If you look at the algorithm in the book or somewhere else, it's really, really tough to understand. And I've honestly worked about 20 problems over this week so that I can come in and hopefully convey this knowledge to you by repetition. So, and I even made out what I think is probably the best little sheets for doing this. And there'll be something like this on the final. And I don't have the sheet all ready for you. So let's get going. We're going to employ Dijkstra's algorithm. So this algorithm, let me just kind of give you the basics of it, computes the shortest distance from one particular node, from a base node to all other nodes, from a base vertex to all other vertices. And if we do this right, if we record things properly on the paper or in the algorithm we're implementing in code, it'll also tell us the route to get there. Like it'll basically give us turn-by-turn instructions on how to get that shortest path. So without further ado, let me just show you this like about 5 times, and hopefully I think it'll work. So step 1 is you have a table. So step 1 is pick a start node. Usually that's given to you. Start node, and when I say node, I keep saying that I mean vertex. Same thing. and initialize your table. So this would be the matrix that you were, or the array in your code that you were initializing. So right off the bat, let me just kind of show you the table. Here's our current node. And that's gonna update. We're basically gonna travel from node to node. We're gonna hit every single node, so they all get a turn to be the current node. We initialize this to be our starting node. So for this problem, A is gonna be my base node for this. If I pick a different node, all the numbers turn out different in this table, and all the results are different. So it really depends on who you're starting with here. And you can't take the information from this table and then go, hey, what is the shortest path info for D? You'd have to redo all that. So I initialize the current node, and then I put the possible nodes in the graph across the top. And you're starting at your initial node, and we're gonna just initialize that with a 0, because the distance from that node to itself is 0. Everybody else gets an infinity. The key idea here is we don't know how far those are, and we're always going to be improving our estimates of how far that node is from our base node. So these are gonna get better as we move down the table. You could put any number you want in here. If you were writing code, you don't have access to infinity. Just put a big ass number in here that's bigger than any possible distance. Put the distance, 9.8 million miles in here. That's the distance from the Earth to the sun. Probably gonna cover your mapping app, you know? So, step 1 is initialize the table. Step 2, and I'm not gonna write this all out because the words will be horrible to write. Step 2 is from your current location, look at all the options you have and take those into account. So from A, I can only travel to B, E, or D. Those are the only things I could possibly update. I can't get from A to C, so we're only working with adjacencies at each step of the way. So from A, I could travel to B. And so I'm going to update, and once you get good at this, you'll actually just not write infinity for the ones you could get to right away. But I'm gonna come in here and update the things that I can immediately. So the distance from A to B is just 1. Now, that was from A, so I'm gonna put a little superscript A up there. And that reminds me that that came from A. And then I can't get to C, but I can get to D, and that takes 2 from A. And then I can get to E with 1, and that's from A again. So now the table's pretty much ready to roll. And here's where it gets a little tricky, and it's harder to write than to do and say. So now I'm going to pick the smallest value out of this row that I haven't used. Actually, let me put a little A here on this one, just to be clear. So I've already visited A, and I'm done with it. And I'm gonna put a circle around that node. So this circle indicates visited. And then I'm basically done with it. Once you've got a node visited, you can just scratch out that table value underneath. So let's make a little table now. So I visited A, put a circle around it, don't need to ever talk about A again. And this helps keep your mind straight. This is what I've learned to keep my mind straight from doing this so much. So I go through and then I choose the next available, and that's key, the next available, like unvisited, lowest value node. I have a choice. Sometimes you will have a choice, that's okay, and you can't go wrong. So notice that I've got 1 in here for both these. I can pick either one. I'm just gonna go with B because it's like next. But I could totally go with E. So here we're gonna choose B, but I'm gonna make a little note here. Could also use A, or E. Could also be E. Can't go wrong. So I'm going to drop B down. And I'm going to circle it because that means I'm visiting A right now, and that reminds me of that. I like to put this circle on as soon as I actually head to the node, because it's going to be something I have to refer for all the other combinations. So we are at node B. Write that over here. That's my current node. I don't have to worry about this column anymore. I don't have to worry about the rest of this column anymore. So the things I have to worry about are becoming less and less each time. So now I come to node B and I ask myself, out of the unvisited nodes I can travel to, what are the distances? So B to C is 2. So I'm going to update this with the current B value. So I'm going to write this in here once. Current, current node val plus addition plus new distance. So this is always going to be part of my combination, this thing in the circle. So it's going to be 1 plus, and then to get to B is, takes me, wait, where am I at? So, sorry, I'm at B. So I'm at B and I can travel to E or C. So I'm gonna go to C, so this is gonna be 3, because it's the current 1 plus the 2 that it takes me to get to C. And I'm going to write my current node as a superscript there. Is that making sense, what I'm doing so far? So check it out. So what's gonna go in D? Can't get to D, right? So I just carry it down. If you can't travel to a node, this I'm just gonna copy down. And it can't be updated yet. So I just take the 2 and the A and just copy those down. Now look at E. I can get to E, and that is a distance of 3 between B and E. So I add that to this current value here, and what do I get? 4. I get 4, but that's not an improvement. So now is where it gets tricky. So check it out. If we take this plus the distance from B to E, I would get 4 units. But I only update if it's an improvement here. So let's maybe write that here. So would be 4, but that's not an improvement. So I don't write it and I just keep this old value. So keep old val and just bring it down, and that stays at 1A right there. So yes.
So improvement from what?
From this current total distance. So you look at this value up here, and this is your current distance from A.
Okay.
Does that make sense? Yeah, so whatever value's in here is your new estimate of how far that node is from A.
Okay.
Does that help? Okay, awesome. Cool, so we've got 1A, we got 1A. I've got another choice because I've got 2 and 3 here. I can pick whatever. Oh wait, I can't pick this one, right? I'm already done. So I've got one choice. It's this one right here. I have to move to E, and so I'm going to carry it down and circle it. So I've got to move to E. So right now, E is my current node. And let's scratch out things that we don't have to worry about. Once you make a node current, you don't have to update it ever again after this time. So now I'm going to look at the distance from E to C. And I didn't give that a weight. So let's give it a weight of 1. It doesn't matter because I don't think we're going to use it anyway. Oh no, I think we are going to use it. Yeah, that's good. Let's go with 1 there. So the distance from C to E, from E to C is 1 unit. When I add that to my current estimate, this thing here, I get 2. And that was, you always use the current node over here as your superscript when you update here. And let me do one more, and then you tell me if this is making sense. So now the distance from E to D is 1. And I add that to this, I get 2, which isn't really going to update this at all. I could make this 2E if I wanted, that's okay, but I can also just bring down 2A. When there's a tie, it doesn't matter. you're just saying that there's two different routes to get there with the same cost, and it doesn't matter which one you pick. So sometimes people have different answers for these different things. So I made this one up on the spot, and there's a lot of freaking ties. The ones we're gonna do together have less ties. Let's just go with C because it's next in line. So we have 2 and 2, let's pick this, bring it down. So I'm gonna say C is my next node. Keeping that subscript unless I update, but I'm not updating when I carry these things down. So I've only got one more piece of work to do. I have to find the distance from C to D, and that is 4 units. And when I add that to this current distance here at 6, that's terrible. I'm not gonna update. So here I just carry this down. It's 2A. This has to be, now I've got one more row here that I need to do. This just gets carried down because it's the only thing I can carry now. And that becomes my current node. There's nothing to update. So once you've got this table all laid out, let me show you how to read the information. The things that are circled give you the shortest distances. Wait, let's see what this guy was D, right? So what is the distance from D to A? Everything that I say is talking about A as the base point. So the distance of D to A is 2. And you come check that out, and you see that you do have that path. There's actually 2 paths there, right? Yeah. This thing tells you the previous node. It's not going to be useful in this table because it's too simple, but we'll see how to use these little superscripts to get the actual path back. What's the minimum distance from A to E? It's going to be 1 unit. Well, most of this stuff we can kind of just read because it's not a terribly complicated graph. But you have every single shortest distance in the circles right here. Let's do a more complicated one unless there's some questions. Yes, sir.
So like, if we go back to the Google Maps analogy, that would be like, this would be one step out of many.
Yes, and so this would be the first thing Google Maps would do, and then probably you've picked one of these nodes ahead of time, and then it would take this information and give you your turn-by-turn route to that thing, which I think is going to be more apparent and a more interesting example. Yeah. Any other questions? Yeah? All right. Here's a more fun one. Yeah, this one's way better. Okay, cool. So let's try this together. We'll do a few together. Okay, cool, yeah. So here's the graph, and we're gonna use A as our base today. So we've got node C. These are chunky nodes. They've got some heft to them. D, and then we've got an F over here, and then we've got a B down here, and then an E. I don't know how Cadence is typing this, I gotta go look. And then G, unless he's like making graphs on the fly. And then here you're making stuff. I have no idea how you're doing this, man. Okay, so there's our graph. Slightly more interesting than the last one. And here's our distances. 1, 2, 3, 2, 3, 2, 7, 2, 4, 2, and 1. So, initialize the table. Give that a try. So, Vincent, you're just going to have to try to. You missed a lot of how this works. But the recording is there for later.
It'll be posted.
You're missing one for D and C.
Yeah, probably.
Yeah.
Oh, thanks. Yeah, good catch. So D to C is 1. Thanks, Tracy. Pretty helpful. Cool. So let's get our table set up, and use these lovely tables that I've got here. I'll make a little copy up here so we can do this all together. We'll have to fill in notes, that's the only thing. So we're starting from A. And so you can kind of see how you can get rid of the infinities right on that first row, right? If you can travel to it, just make the estimate as opposed to popping an infinity in. First row should look like that after we get everything initialized. And if it doesn't, let me know, maybe I screwed up. We looking good? Yeah? Alex is taking some photos of that.
I can't really see it without my.
Oh, really?
Yeah.
Oh. Get you some like opera glasses to like hold up, you know,
Yeah.
be very haughty, get a powdered wig and, yeah. So where's our first, circle this guy, where's our first node of travel? D. So we're headed to D next. That's the minimum. So we bring that down, circle it, it's our current node. And then work from there, estimate. Oh, yeah, and then you can also like just cancel out everything under A and everything under D. You don't have to mess with that anymore. These squigglies makes it a little more apparent. Yes. Sorry, yeah, I can totally do that. Yeah. So when I made these little sheets up, when you do have a graph, you can draw it on the top. Like, I'm not telling you to do that now, but that's what that little space is for. It's like ergonomically. So are we gonna update C? Let's talk about that together.
Yes.
Yes, we are, exactly. So when we go to, we're starting from D, that's our current reference point. The distance from D to C is 1. When I add that to my current total, I get 2. So I'm gonna put a 2 here, and I'm gonna label it as D, because that's the reference point right now. And it's less than the 3, right? So we improved the estimate on the distance. Let's see. B. Oh, B doesn't get updated because it can't reach it. E doesn't get updated, so it stays infinite. F gets updated. What does F get updated to? 3. So the distance from D to F is 2. I add that to the current total right here, so it's going to be 3, and I label that as a D for the current node reference point. And then we can't make it to G yet. So your next row should look like that. Where is our next node to travel to?
B or C.
B or C, is everybody cool with that? Like I can choose B or C? Sophia, are you doing good?
Yeah.
Okay, do you want to talk about anything?
No, I was doing the math with the
Oh, I'm sorry, I didn't mean to break your
Oh no, you're good.
I didn't mean to break your stride.
You're
Sorry.
okay.
Okay, cool. Awesome. So let's all go with B, just so that we're on the same page. Otherwise, our tables will look totally different. So we'll go with B. So bring down B. That's your new node. Circle it. Scratch out everything under. You're done with that column. So now we're at B, right? Yeah. We don't have to go to A, we don't have to go, we just gotta go to C and E. Yes, Cadence.
For B to E,
B, this next one I was about to do, yes, yeah.
do you add the previous path? So it'd be like 2 plus 3?
Yes, exactly. So yeah, from B to E is a distance of 3, and I always add that to this circle. Yeah, so
Anytime something gets updated, add the circle.
correct. Yeah, the circle is your base for all updates in the current row. So yeah, so that's gonna be 5, and we were at infinity, so definitely we've improved our estimate, and that becomes 5B. B to F. Can't do it. So can't do B to F, so just bring down the 3D. And B to G can't be updated. So do we all agree that our next current node is gonna be C? That's my minimum out of 2, 3, and 5, and infinity. That's the winner. So my next node I move to is C. Then we have to worry about E and F as our nodes to update. Notice that you will update E, the CE location. Is that right? Yeah, because it's 2, and add to that, so I get 4 from C. Or 4 through C. And then F. The F is freaking horrible. That's 7, that gives us a 9, we're not gonna update that. And we can't make G from C, so we don't have to update that. So your next is F, it has to be, that's the best distance out of that row. So you bring down that F value, make that your current node. And then just 2 more things to update, right? F to E is 4, I got that to the 7, so we're not gonna update that. F to E stays 4. And F to G is gonna definitely upgrade. Oh, that's sweet. So that's just a total of 4 through F. And then since we have a choice, let's go with the E next. Just like working left to right, you know, is kind of a nice flow. If you can, when you make those choices. So we're gonna choose E. Oh, careful. Circle that. And I've only got one more comparison to make. That is going to be to G. So E to G is 2, add that to the 4, that's 6. It's more than the current value. So we just bring that down. And then we just bring down the G for the final move. And we're good to go. So let's make sure we can get there to this table. And then we can talk about how to use it to get paths as well. Any questions on this? Anything you want to talk about? Anything you think I got it wrong? What's this? I freaking love this. I'm so glad you think this is cool, because I love it too. It's really neat. So let's talk about how to use it. This was supposed to be F. Now implementing this in code seems like it could be a challenge, right? Just with all the arrays and stuff, but it's not that bad. It would actually be kind of fun to write it in code. But it's really fun to do it on paper. When the world melts and we don't have tech, on our island, we're set to find shortest paths around the island. So after we build a ruler and a clock, those are the first things. So if I want the shortest distance between node A and node F, the answer is 4. So the distance, best distance,
Between A to G.
A to, yes, thank you. Yes, thank you. Good. I just saw that. It just kind of out of dumbly wrote down F. So distance from A to G is 4 units, whatever those are. That's hours, miles, whatever you got. The path is this. So check it out. This says the previous node was F. So to get to G, I came from F. Then I go to F. F came from D. That's what these superscripts are for. Where did D come from? D came from A. And there's my best path. So you use those superscripts to unravel the path backwards. And then you print this out for the person who's driving in forward. So that's freaking awesome. I don't know, it's crazy that it works. Let's do another one. Unless there's more questions. Because I like I said, I've been having a lot of fun with this. And yeah. Okay, hold on. Now that we're good at this. Oh, hell yeah. Let's do this one. I don't know if I gave this handout or not. It doesn't really matter. I'm going to put the graph up for you. I didn't give it out today for sure. So this one has A through G. And if we can do this, we are absolute masters of Dijkstra's algorithm. B, C, and then that's 1, 3, 1. And then we go to G there, and that's 2. B cuts across with a distance of 7 to D. And then G to D is 12. You know you're not going to be using that one. And it's like a good bet anyway. And then we go to E, and that's 3. And then C to D is 9. And B to E is 5. And D to E is 2. And then we got one more node, and that's going to be F here. And that's 1, and then 2. And then there is one more path. Like digging a hole through the ground or something. 10. So let's do this with A as our starting node. So start here and find the shortest path to every other node using Dijkstra's algorithm. And that sheet you got in front of you. You guys got these, right? Yeah. Okay, cool. These are that's the way to roll with those.
Question.
Yes.
So what?
Those are distance or time or something like that. Yeah, they're weights in general.
Do you find those at all?
They're given. And there's a couple choices in here. Go ahead and just make whatever choice you want. But preferably let's work left to right if we can, just for today while we're together. You get the same answers at the end, but the table flow will look different. Except for A. Run the restroom. Back. probably shouldn't change it now, even if it was something different. So, it's B to D is 7, okay. That's it. Oh, and G also, right? Yeah. Yikes.
You're forgetting about the A to F,
Wait, where?
the A to F,
A to F.
the 10.
Oh, sorry, what I just did there?
No, just like,
Wait.
the A to F. No, the one that goes directly from A to
Oh,
F.
thank you. Oh, shit, I am. Oh, gotcha, yeah. Oh, yes, thank you. Holy hell, yes.
Just before you wrote too much.
Thank you, I appreciate it. Yeah, so A does go to F. I like added that dumb thing on and forgot about it. So, yes, thank you. Yes, thank you. Thank you. Oops. That was infinity, so thanks, Cadence. Your check will be in the mail. So let's see, so we got A, and then this B does not connect there, thank God, so nothing too bad. Thank you, sir. Better? Yes, okay, good. I really appreciate it, because I would glad I didn't get to the end and have to redo this. We'd just cancel. C to D, be like that one day where I was so frustrated with myself, I was like, that's it.
We're done.
We're not doing class ever again. D to C, that's 9, so that's pretty bad. That's not gonna improve things. C to E is 3 plus, oh, so that goes up. C and C to F doesn't exist. C to G does not exist. Cool, so we are now G. G's actually our best. Bring that down, pop a G over here, scratch that shit out. Okay, so now we're based at G. G to D is freaking 12 plus 3, 15. That's not going anywhere. G to E. G to E does not exist. G to F does not exist. Love it. That makes life easy. Is this looking good so far?
Add it to the
Yeah.
current
Okay, cool. So then, D, where's our, E is our next choice, right? Yeah. So we pick E, bring that down, make that current. Almost done. E to D is 2 plus 5 is 7. And then E to F is 2 plus 5 is 7. All right. Good. We pick a choice. Hopefully we pick the left one, because that's what I'm doing. And then this is all dead. So we got one last distance to compute, and that is, wait, where's that? E, D. So D to F is 1 plus 7 is 8, no update. And we're done, just copy that guy down. And our last node is F. So let's make sure we all got the same tables. Thanks to Cadence, there's a hope that we can. So then, if I wanted the path from A to F, this is the part I kind of like doing. I don't know why I like this part so much, the unraveling the paths, but it's fun to hop around these tables. So the best path from A to F is 7 units long. And it starts at F, and then it goes to E. And then E takes me to C. and then C takes me to B, and B takes me to A. That's so beautiful, so freaking amazing. An elegant algorithm is a fine thing. How do we feel about this? We do this? Let's do it here. So there's 2 of these, I think, on the web work, or 1, or 2. But I'm gonna put a bunch more stuff up, so I'm gonna create, like I said, a practice exam and have that up hopefully tomorrow, the latest Friday morning for you. I was thinking about just doing office hours by appointment next week, so if you just wanna meet with me, I don't wanna like sit around for hours just waiting for no one to show up. So if you wanna meet with me, just send me an email and we'll we'll rig something up. Does this sound good?
Oh, will there be tables like this on the exam?
Yes, sir, of course, yeah, absolutely. Yeah, there's no better way to do it than with a nice table like this. So that's why I got some extras here for you. Let me hand out the rest so that when you're working these, do you want to do one more or do you feel good about this? One more? I thought you were giving me a thumbs up there, Daniela.
No, we feel good about
You
it.
feel good about it? Okay. You're like, no, please don't give us more. No, I'm glad you feel good about it. That makes me happy. Here's more of this shit. I'll put a PDF of this up if you want, so you can have it to like play with and practice. And let's see, let me get these guys need some more over here. How many of these did you guys get? You just got 1 each. Here's more. You're welcome. Double-sided and everything. There's more.
What do you mean when you ask how many components does a graph have?
Oh,
That like
guess we didn't really talk, yeah, so that's a good question. Hold on, let me answer that one for everybody. Here's more. I know. You know what, you know what? You can just email me and I'll always send you one for the rest of your life. Literally.
Okay.
Yeah, you got it. Why not? So Yvonne, what question is that?
It's just how many components does a graph have?
Which number was it?
Problem 3.
3?
It's in the web work, yeah.
Yeah, but it's number 3?
Yeah.
Okay. So web work 3 is number of components in the graph. And that just is talking about connected components. So a component is the largest connected piece possible. So let me show you what I mean. So if I have a graph that looks like this, this has 2 components. So I'm looking for the pieces that are connected, and that's a component. Does that make sense?
Yeah.
Yeah, cool.
Okay, cool.
So, our exam next week's on Wednesday?
Yeah, let's talk about that so that we all make sure we have that info. Let's make sure we put that in our phones. And so yeah, let's talk about it. It's next Wednesday, 10:10 a.m. right in this room here. That is 10:10 a.m. December what?
7.
December 7th here in this room. Got a phone? We'll put that in our phones. Let's make sure. If you miss the final, I'm not giving you another final. I know you know that.
We don't have to be here at like 8 a.m.
Oh, I know. I have an 8 a.m. final. I canceled it. Yeah, we're not doing that.
I would not be like awake enough for that.
It sounds shitty. Super shitty. Yeah, it's too cold to get up that early. It's terrible. Yes.
We have finals on Friday, but they're also kicking us out of the dorms on Friday. Isn't that
Are you
crazy?
serious?
Yeah.
That's actually room for complaint.
Yeah.
It was that way last year too. I had to drive down.
I have a flight at 4. Like,
You can apply for an extension, but they make you pay like $35 extra.
yeah.
That is
Even
a
if it's
racket.
because of waiting for
Right.
travel is. Also, one of my friends is on the Spirit team, and they were supposed to have games on Friday and Saturday for basketball. And you know, if they're kicked out of the dorms on Friday, how are they going to do that? So they were going to have to pay for the extension to do a Regis sponsored thing in a Regis club.
Unbelievable. That's bullshit.
Yeah.
Okay, now that I've said enough on tape, let me close this.